Well, welcome, folks. I think we'll go ahead and get started. For those of you who don't know me, my name is Erica Albrecht. I'm with HDR here in our Louisville office. I want to welcome everybody to the structures room for this virtual partnering conference. See a lot of familiar folks on the attendee list, so welcome everybody. Want to go ahead and introduce JC and Clayton from KYTC Business Structural Design, the Geotech branch. They're going to talk to us a little bit about geotextile fabric. Also want to thank you both for taking the time to prepare your presentation and put this together. So take it away.
All right. Thank you, Erica. All right. See if I can get this going.
I'll step off here too, JC.
Oh, okay. All right. Is that popping up, Clayton? Or thumbs up? Okay. Like Erica was saying, my name is JC Wilhoit. I work for the Kentucky Transportation Cabinet. I am part of the geotechnical branch, and I am the supervisor over the soil survey and test section. Basically, I am in charge of most of the roadway reports, if you all are involved with that at all, and also a lot of the lab testing. I work with that. First thing, though, I wanted to do was I was wanting to kick out a poll. So if you all can attend, and there's a reason I'm asking this, if you all can go ahead and answer that. So we have a few responses. I'm actually learning to do this myself. We started school a couple days ago. So while I'm not very qualified, I am trying to learn how to be a homeschool teacher, and this is great. So if something crazy happens, that's just a little background of what's going to happen. If you hear a dog barking or a little girl screaming, that's my daughter. So it looks like most people don't have that excuse. But anyway, the subject matter for today, we're going to be talking about the cement versus lime stabilization, and we have a site study. I've kind of cleansed this a little bit. It's an ongoing project, and there's still a lot of people involved that are active. The purpose behind this is not to really throw anybody on the bus or try to cast anybody in a good light. Really, it's just kind of a lessons learned and what we want to do moving forward. So with that, let's get this kicked off. Let's see. Just a little background on this project. This is a design build project, and at KYTC, we're kind of new to design build. It's been going on for a little while, but we're still learning a few of the nuances of it. But since it is kind of a newer thing that we're trying to do, we really wanted to stress that we wanted to minimize change orders for this project. Something that's different from a lot of design build type projects is we provided some design criteria prior to any of the sampling and testing and prior to the bidding process. Like I was saying, the bids were based on this design criteria. So since we didn't have a lot of information to go on, we had to do a little bit of guesswork, and that kind of led to this whole presentation. And one other background is this project is located in northern Kentucky, which will kind of give you an idea, if you're used to working in that area, what kind of, what we should be expecting as far as the soils go, the geology, that stuff. So the design assumptions that were sent out in the bid package was that we will be using some sort of stabilization for the subgrade. Pretty much all projects now moving forward, we're going to try to do something. Historically, we may not have. We could have went more with the soil subgrade, but one way or another, we're going to try to use something, either a mechanical stabilization or a chemical. So we threw out there that the CBR of 3 would be used for your pavement design. Maybe a little high for northern Kentucky, but it's viable. Durable rock will not be available, which is a good assumption. Everything out there is pretty much going to be a non-durable shell when you actually get to bedrock. And the chemical stabilization will be used, and it was specified that cement will be the chemical that is used for stabilizing, and that is based on a 6% weight. Okay, so now that was out there, we threw that out there for the bidders. They put their packages together. It came with the whole design team for the highway design, the geotechnical engineering, and the contractor all in teams. They started to submit their plan back to us, and that included and this is the geotechnical part, and it only included in this slide is just for the roadway testing, the profile testing, not including all the structures. So there were over 60. I'm going to check, and I right in the middle of this too. If you all do have a question or anything, just go ahead and throw it out there, and I'll try to answer it as we go. If you do have a question. So there were 60 borings specified. Of that, we got from those 60 borings, we got 53 bulk samples. Now that's kind of a high ratio for typical, but the spacing on the borings was a little higher than what we usually do. So that's really pretty much why we had such a high ratio of samples to boring locations. And it's fairly standard. The testing included soil classification, moisture density or Proctor testing, and CBR testing. So everything so far is going pretty normal. And some of the results from that, if you're not too much into the geotechnical area or the soil testing part, this may not mean a lot, but really moving forward, if you're going to design or use this for pavement design, I'm just going to try to go over these real quick. So using chemical, it'll kind of start to sway you one way or the other. So we had 53 samples, and of those, 1 was a sand. Everything else was a clay. Mostly moderate to low plasticity clays, or CL, if that's what you're used to seeing, and 15 high plasticity clays, or CHs. The whole of all the tests, the plasticity index, which is the difference between the liquid limit, plastic limit. You don't necessarily need to know that if you just want to look at it and just see what the number is, just to know. But the range of that went from 46 to 12. Now, if you're familiar at all with how we like to stabilize or use chemical stabilization, you'll know that that's going to start swaying us one way or the other. And then the percent fines, that is silt and clay sized particles, everything smaller than a number 200 sieve. That ranged with a minimum percent passing of about 41%, and a maximum of about 95%. The reason that is important when we're talking of chemical stabilization is we have criteria. The criteria that we provide in our manual, our updated manual, it basically we break it down into use cement or use lime. If you see if the PI is greater than 15%, fines is less than 35%, we like to use lime. On the other side of it, if it's less than 35% fines or less than 25 on the PI, we can use cement. Now you'll see that there is a little bit of an overlap in the PI. It's kind of a gray area between lime and cement as far as the PI goes. That's where if you get the lab results back, you can start to kind of put them in different categories. And here, I also wanted to show, this is a little bit more on the national level. We don't necessarily use this, but I did want to show that the FHWA, when they start to categorize what is the proper treatment, they look at the, first and foremost, the percent passing, the number 200 sieve, that's the metric equivalent, and they break it down. If you'll notice, all of our samples had more than 25% passing, so we're already automatically on the left side of this chart. And then they start breaking it down by the plasticity index, the PIs, and you can see that in our range, we didn't have any in the far left. The PI is less than or equal to 10. Several were between 10 and 20, and then several were greater than 20. Looking down, you can see that the cement for stabilization, we're looking at not suitable if it's white, and if it's that hash, it's a doubtful. Lime, as opposed to it in the row below that, you can see that with the PIs 10 or greater, it is usually suitable. So we're starting to kind of get an idea of what the proper treatment would be. I kind of just made this chart, maybe make it a little easier. And this is based on the KYTC criteria. On the left, you can see based on PI, we had 2 that fell into the hard into the cement category. 16 fell hard into the lime category, and 35 were either or. However, if you look at the category based on percent fines, every one of our soil samples came back at a percent passing greater than 35. So we have a lot of small size particles. So we're starting to get skewed towards lime. So as you can see, just to sum all this up, the KYTC criteria, all but 2 were for lime. The FHWA criteria kind of back that up. Also, the consultant geotech firm also had a recommendation of using lime for our chemical stabilized subgrade. However, the bid was based on cement. The contractor prepared the workforce based on cement, and their timeline is based on cement. Now, if you're not familiar with the differences between the two, lime does take a little bit longer to work. You have to mix it, come back the next day after you let it mellow, because it's actually a chemical reaction that's occurring, and then you remix it before you compact it. Whereas cement, you pretty much have to do it right then. You spread it, you mix it, and it has to be done because the cement's going to start setting up. So there's an extra day involved in labor and a remixing that is always involved in lime. So it may be a little bit faster, cheaper, however you want to look at it. So when we presented these results back and we're working with the design team, there was going to be a significant cost increase if we changed from cement to lime. So where did that lead us? Well, so now internally they asked us to evaluate both types to see, is cement, is it even viable for this type of soil on this project? If so, we're going to try, and just because we've done this in the past, we've used 6%. We also upped it to 9% just to see how it would test out. And then we also tested lime to see what's the difference. You know, is it going to be a lot better? But that required us to obtain more bulk samples because the consultant had done this before. All their samples were gone. So now we had to obtain more bulk samples. In our lab, we prepared these specimens and then we performed strength testing. Now, I'll show you in the graphs following this, we kind of use 80 PSI as a compressive strength just as a baseline. It's not really specified that that's what it has to be. It's just something that we use for if the contractor requests to get on it in a shortened curing period. So that was just a baseline we threw out there, but it's not necessarily like a hard line. This is what it has to pass. So with that, the test results came back. We started with a 6% cement, and these were all being pulled out of the same bulk samples. So we ran 11 tests, and you can see that all 11 failed to meet an 80 PSI. Again, that's just a baseline that we were going across, but you could see the strengths weren't really getting up very well. Some of them around 50 PSI at the time of testing. And just a quick note, we used our resilient modulus compressive cylinder to form all these. So it's really kind of an apples to apples comparison. They were all compacted in the same way, and they're all basically coming out of the same bag. So there's the test results for 6% cement. We upped it to 9%, and you can see now we actually cut the 6% cement off after so many tests didn't meet. We figured there's no more point in testing. We did additional samples with the 9%. You can see out of the 16, most of them met 80 PSI. Some of them got quite a bit higher. A few of them were lower. Those were typically going to be the CH materials. They had some trouble gaining strength. And then finally, we had a 6% lime mix, and this was at 7 days curing, and all the tests met a pretty significant strength increase. The scales are different on these charts, but you can see all the tests met. So we had some pretty good success. And then all together, this is a chart. So you can see the 6% was significantly lower. The 9% was a little bit higher. We had a few outliers that were low, and it was but significantly improved over the 6% cement mix. And then the lime was, you're just looking at it from the samples, it was obviously quite a bit better. So the result of that, we had presented our data. The design team and KYTC, they elected to stay with cement, basically because the strength gain didn't justify the increase in cost. There was, like I said before, there was a cost increase, and we couldn't justify that change at the time, especially with, you know, budgets as tight they are. We had already allocated the funds for it, so it's really difficult to make a change. But we did get some caveats in there. With the cement was going to be increased, particularly in the fast track areas. I think we could pay for the KYTC agreed to pay for additional cement, just to make sure that in some of these areas we were going to get the strength we needed. The contractor said they can mix twice if the soils appeared clayey, and so that would actually kind of help break down a lot of the problems with this with using cement. Is you'll see in a little bit, the difference between what's going on in the field and what we did in the lab, we actually were running those over a number 4 sieve. We were breaking the particles down pretty small. When you get out in the field, it's going to be a lot harder to do that because we're handling a very small amount and we can manipulate it by hand versus what you're going to do in the what we're going to do in the field. Sorry, I just saw a chat pop up. So if you all have ever seen the setup, and these are pretty fresh. This is from about a week ago. This is the cement is already laid out over the subgrade. The contractor is out there. That is a water truck getting pushed by the actual mixer. And so it's adding a little bit of water. There is some water that's required to get, you know, obviously to get the reaction to start. And so if this is your first time seeing it, that's kind of the basic setup. And I have a video real quick just so you could see what it's like. I hope this works. So you see they let this go. Let's get back here. So you can see that that it actually, I mean, it can move pretty quick. That was actually without the water truck. That was actually a first pass over, and what they were going to do is not add water on the first pass, and then they did a remix to add the water at that point. The thing is, when you see this, and this is me taking a picture. I had some keys in there for scale, but you can kind of start to see that there are some larger clods. Sometimes the soil is not getting broken down, and what you can end up with, instead of, you know, a really homogeneous mix, you kind of end up with cement coated clods of clay, which is not really what you want. You want it to be mixed a little more thoroughly, but it's really difficult to get that because these soils are so cohesive. Let's see. This is a quick check we did. So we pushed a kind of a little tube sample, and you can see we put some, if you can see the coloring, it's phenolphthalein is just an acid we poured on it, and the dye actually kind of comes out purple when it comes in contact with the cement or lime. You can use it for either one. You can see we pushed it about 9 or 10 inches, and we were still detecting quite a bit all the way throughout. It's just a good quick check to make sure that we're getting our mixing depth and it's getting mixed fairly well. This is a in situ strength test we did real quick. It's just a DCP, our cone pentrometer, and you'll count the number of blows as you're going down through the subgrade, blows per inch, or whatever kind of metric you want to use. And then you can come back and test it, you know, as time passes, a few days, to see as it's gaining strength, are you getting a good strength gain? And also we're testing this pretty quick. You can test several spots just to make sure that, you know, it's getting somewhat similar test results. You don't want to have really strong spots and weak spots. And here we have, after they put, you can see there, after they compact the subgrade, they'll put a tack coat down, and then we come back in a few days after that, and we'll actually take a core of the subgrade. Again, we did the acid drip test. You can see that it was still a pretty good mix, and you can use those to get another strength test to make sure that we're getting the kind of strength that we're wanting to get out of the subgrade. So, like I said, these are pretty fresh. This is construction is ongoing, and the stabilization efforts began in the first week of September. So here we are. So these are pretty hot and fresh. We don't know how the end result is going to be, but again, from the lab testing, you kind of see, had we known early on which way to go, we may have went with lime as a better alternative, or if we could have negotiated a little bit better, that may have worked. It just was really difficult with the way this project was set up and where the funding was already secured to make changes that were that significant. But hopefully, if you all as pavement designers or as designers in general, trying to know what region you're working in, that may kind of give you a good idea of what kind of chemical stabilization you may want to use. And also, I know a lot of people kind of push towards cement. Sometimes lime can be a very good alternative, and you can see just from the strength test results, it does gain strength, especially if you're going to deal with really fine-grained materials and materials with a lot of cohesion. And with that, if you all have any questions, I don't know if you want to do it at the end too. I guess we can open it up, and if not, I guess Clayton can take over. I must have done a pretty good job. Does the KYTC spec use micro cracking? I am not familiar. I like the next comment better yet. Thank you, Jason. I don't know. I don't believe we spec out micro cracking. And I think Tony may be here if he knows about that. Like I said, Tony Beckham, he is kind of our resident expert on this, and he helped put this together, but he's maybe in the audience if he wants to chime in. If not, but James, I don't know. I'll have to look at that. Yeah, I guess you can take over. And again, if you have any questions, I will do this again at the end. If you think of something, just whenever.
Cool. Thanks, JC. I'll switch over to the slides then if no one else has any more questions.